Hey everyone, welcome back to another video by Camroom 5. Today's video is going to be about the concept of isomers from O-level chemistry, but we're going to be talking about the naming and obviously isomers based on the new syllabi for chemistry. So when we talk about isomers, we have a very clear definition that these are the compounds with same molecular formula but different structures. In order to understand this more deeply, we first need to understand the concept of naming, or as it also goes by nomenclature in organic chemistry. So for nomenclatures, we have some rule. When we try to name an organic compound, we have some rules. The rules are going to be more easier for us to understand once we keep practicing them using the structures shown. Now, look at these two structures you have, one on the left, one on the right. These two are obviously hydrocarbons. They have just hydrogen and carbon atoms. But they look some branch structure. They are not very easy to understand what's going on. So when we talk about the rules for naming, the first rule is that we identify the longest carbon chain. The longest carbon chain. And when we talk about longest carbon chain, we obviously do not include the branch. So do not include the branches. For example, the structure on the left hand side, you can see that there are 4 carbons in a continuation, carbon 1, 2, 3, 4, and there's a branch coming out from carbon number 2. There's a branch coming out from carbon number 2. In the second rule, what do? In the second rule, we number the carbon atoms from the corner closer to the branches, unless the branch is exactly in the middle. So first we identify the longest chain. For example, in the structure on the left, 4 carbons, and they were like in a continuation, and then we have a branch is coming out from carbon number 2. Then in the third step, what do? We identify the branch as methyl. Each branch is called a methyl. Technically, methyl means a single carbon branch. So we identify the branch as methyl and its position number. So we not only identify that whether a branch is there or not, we also identify which carbon the branch is coming from. And then we name it. So the name is going to look something like this. 2-methyl, and then we call it butane. Now why do we call it 2? The 2 represents the position of the branch. 2 represents the position of branch that is on the second carbon. The methyl represents a branch. Methyl technically means a single carbon branch. And butane means the longest chain apart from the branch. The longest chain except for the branch. Now let's talk about the structure on the right side. You can see that there are multiple carbon atoms, but 1, 2, and 3 carbon atoms are in a single row. So they represent your longest chain. And then you can see there's a branch coming out from carbon number 2. So you will call it 2- then methyl, and then you will call it propane this time. Again, the 2 means that the branch is coming out from carbon number 2. So the position of methyl branch is position 2. Methyl means a branch. And then apart from the branch, what do we have? Apart from the branch, we have a 3 carbon long chain. So that is a 3 carbon chain called propane. So 2-methyl propane. Now since we have understood the idea of naming a little, it will help us to draw isomers in a better way. When you look at a 4 carbon compound, which is generally called butane, but now based on our understanding, we should be able to figure out that even a branched carbon can be similar to butane in molecular formula. You look at this structure, this is called 2-methylpropane, but it also has 4 carbons. So butane and 2-methylpropane, they both have 4 carbons in the structure, they both have 10 hydrogens, they both are saturated. So you can see that butane has no branch, but 2-methylpropane has a branch. This one is an unbranched 4-carbon alkane, and this one is a branched 4-carbon alkane. Both are alkanes, but this one is called butane, and this one will not be called butane, this one will be called as 2-methylpropane. Molecular formula for both is the same, C4H10, C4H10, but in this case they're going to be called as different names. Another example for isomer would be when you have a 5-carbon compound. So for example, you have a pentane like this, and you have a 4-carbon long chain, but you have a branch coming out from one of those carbons like this. Like this. So you have a 4-carbon long chain, or you have a 5-carbon long chain, but with the 4-carbon one you have a branch coming out. So carbon 1, 2, 3, 4, 5 in a continuation called pentane, but carbon 1, 2, 3, 4 and a branch would be called as 2-methylbutane. One of them is unbranched, other is branched. They are isomers of each other. They will be isomers of each other. I hope this idea is clear, because in the next video we're going to talk about the naming and isomers in alkenes. Stay tuned guys. Thanks.